Now, um, when we do experiments, keep it simple. More than two independent variables will give you a huge headache. Unless it's absolutely necessary, don't swim in that troubled water. So for example, if you want to investigate the effects of gender, race, and age on helping behavior, now you have three IVs, right? Gender, race, age. You are going to have three main effects to investigate four interaction, AB, AC, BC, and ABC. And if you have four IVs, there will be in total 15 effects. Not only it gives you headaches, you're more likely to find some significant result just by chance, right? So keep it simple. Two is yeah probably good enough, and three probably is maximum. You don't want to do it much. Now, how to decide what to design? This is just for your reference. You can take a look if you want, but it will not be on the test. All right. Um, Another thing we want to talk about is correlation. First, I want to show you is a correlation matrix. So when we have a lot of variables and we want to investigate their relationship and the relationships among them, we do this matrix. So you can see one is cultural adjustment, two perceptual support, three shyness, four sociability, and five groups actually is Asian versus American. All right, so we investigate, we know, analyze the relationship between among them. So you can see five, one, two, three, four, five right here. Uh, this is a mean and the standard deviation. Now this is one, two, three, four, five. So that means this is also cultural adjustment, procedural support, and so on and so forth. Now this is one and one, the correlation. But of course, it correlate with this itself. It should be one. So we skip this data. How about procedural support and cultural adjustment? So this is one and two. It's 0.69, which is very high. And then this is a 1 and 3, shyness versus cultural adjustment, and sociability and cultural adjustment, and finally groups and cultural adjustment, and so on and so forth. That's the matrix, right? Now, in complex correlation research, we can do this. And if after this, we also want to study relationship among a large number of conceptually similar variables. Then we use a complex statistical techniques called factor analysis. Um, that factor analysis only reveals the underlying structure of the variables. In other words, this factor analysis will put all the seemingly related variables together. So a good example is Big Five, um, the personality traits. After a lot of analysis, we find a lot of terms describing people can be grouped into five factors, and that is the work of factor analysis. Now, sometimes a complex correlational research is helping us to explore possible causal relationship among variables. Now, it's correlational, so it's not exactly, telling us a cause and effect, but we can from there get some hint, get some evidence. So through the statistical control of a potential third variable, the control it's accounting for third variable by measuring them and include them in the analysis. And sometimes we can just remove that third variable and see what the correlation is left. Okay, and this leads to a very effective tool called multiple regression. It's a technique that describes the relationship between multiple independent variables in a single dependent variable in terms of equation. It shows the separate contribution of each independent variable to the dependent variable. And in multiple regression, we actually call them predictors and criteria. But Be careful. Predict does not mean cause. So for example, I want to investigate what are the factors that influence people's GPA. Maybe how hard they study, how hard they party, and also their concept of academic achievement, how much they perceive that as important. So we have three predictors, right? And the criterion variable will be their GPA, right? And so we collect the data, we ask people, get the data, and plug in, use these predictors, and see how much they predict our GPA. But we are not saying these factors causes GPA. It could still be the other way around, or maybe there are some variables we didn't cover. So again, remember when we say predictor, we are not saying this definitely causes that criterion variable. The good thing is it can show whether an independent variable makes a contribution to a dependent variable. In this case, example, this GPA, and above, over and above the contribution made by other independent variable. In other words, the three variables we just discussed, it can kind of show us which variable probably is which predictor probably is the most important.